Hubble is going blind for the second time. Not in a week, not sometime later. Right in the window when that same false star, not listed in any catalog, is supposed to flare up again near 3i Atlas. The first time, it seemed like an unfortunate coincidence, the kind that happens to any old device. The second time, the coincidence begins to resemble a schedule drawn up not by engineers, but by someone who knows where we'll be looking. There's a detail that makes people inside NASA go cold. Before entering safe mode, telemetry shows a nearly identical sequence of events, as if there hadn't been a breakdown, but rather a careful transition to protective mode, using the same method. In the public version, everything sounds flat, dry, and familiar. System overload, sensor failure, automatic protection. But inside the report, there remains a line that people don't like to even whisper: pattern repeatability. And right now, instruments that don't rely on a single space telescope are already being deployed around the world. European observatories, Japanese stations, private domes, even several university arrays that aren't usually assigned primary targets. The plan is simple and rigorous. We confirm the false star simultaneously in multiple bands. If it's real, it can't be a flare. It can't be an atmospheric tremor. It can't be a sensor error in a single camera. A false star isn't just a fancy name. It's a point source near an object that appears to be held relative to 3i/ATLAS, as if bound to it by invisible, rigid geometry like a module near a ship. It had already appeared, briefly. And then something strange happened. In several independent frames, it sat in the same position relative to the comet, even when the exposures were taken at different times. A normal star doesn't behave like that. A star is background. A comet is motion. If a point stays close to a moving body, it's either physically nearby, or it's an effect tied to the body, not the sky. The first time this came up, scientists argued frankly. Some said it was noise, others a satellite, others a cosmic ray, and still others a rare dust geometry creating a knot of brightness. But the dispute ended not in argument, but in silence. As soon as several groups attempted to assemble a common set of raw data, access to some archives was suddenly policy restricted, and the discussion retreated into closed channels. And now, a second chance, and simultaneously, a second blow. 6 hours before the window when the false star is supposed to repeat, Hubble begins to show the same precursors as last time. First, a slight jitter in orientation that doesn't fit the typical reaction wheel model, then a series of short, overly frequent corrections as if the system is trying to maintain its target but is being thwarted. Then the flow of events in the logs grows, as if several sensors simultaneously began arguing about where up is, where the sun is, where the stars are, and all this looks not like chaos but like steps on the same staircase. The engineer on duty sees the numbers and realizes he's seen them before. Not similar. These are precisely these intervals, these pauses, these surges, like a repeat of that very melody, unmistakable. No one shouts in the control room. They don't like shouting there. They like to test hypotheses, but you can hear people's breathing change as they scroll back and compare timelines. The pattern matches. Not 100%, of course. You could always say the conditions are different. But the coincidence is too recognizable to ignore, and the most vexing question already hangs in the air. If this is a repeatable sequence, then what triggers it? And most importantly, why does it trigger precisely when we're about to see something we don't want to see but must check? The official meeting is convened quickly, but without fanfare. The list includes people from various departments, orientation, food services, software, security, and the research team, and a few more guests who aren't usually invited to such discussions. The conversation begins not with reasons, but with a schedule. We have a window. We have a goal. We can't afford to lose another opening. And then there's silence, as everyone realizes they've probably already lost it. Hubble enters safe mode exactly as if it has no choice. It turns off its scientific instruments, locks its orientation in a safe configuration, and drops its payload. Beautiful, clean, textbook. But for engineers, the textbook doesn't answer the question of why textbook-like behavior only occurs during those moments when an object should be most visible. Two coincidences are already making it difficult to sleep soundly, and this is where things that can't be broken with a single switch come into play: the Earth, ground-based telescopes, amateurs who haven't signed strict protocols and aren't waiting for permission to publish. While Hubble remains silent, the false star should emerge without it. If it's real, it will be visible in images from those who watch long enough to cut through the noise, and therein lies a fear that's rarely acknowledged. An amateur might see things that the official structure won't have time to hide, not out of malice, simply because they're not built into the system of pauses and approvals. The first phrase appears in the chat of a small group of observers. There's a dot. At first, it's dismissed as a typical error. Too often, people see a dot where there's simply a hot pixel, but a couple of minutes later, a second message arrives from another country with different optics and different weather, point at the same offset. And now, this really gets on my nerves, because a coincidence by offset isn't just, I imagined it, it's geometry. It means two independent systems, without collusion, saw the same feature in the same location relative to the target. Someone posts a crop, someone else posts exposure settings, someone asks to keep quiet until we check. And in that very moment, you feel the world being divided between those who want to prove it and those who want to close it. At NASA, it's not just engineers who start working at this point. People who handle things that aren't officially discussed are also involved. Information windows, access, publication delays, and coordinating wording. Because if the false star is real, the next question is inevitable. Why does Hubble shut down just when it should appear? And why does the telemetry before the shutdown repeat the same scenario? Surprisingly quickly, a single phrase, short and unpleasant, pops up in a closed chat. If it's an external influence, it knows the schedule. No one specifies what exactly is meant by external, and then a third frame appears. A third observation point, a third point next to 3, I/ATLAS. And now the debate is no longer about whether a false star exists, but about what it is. If it's a cometary satellite, it should move according to a clear dynamic. If it's a reflection from a structure, it should behave not like a star, but like a geometric marker. If it's an emitter, it should leave a spectral signature, and that's why the second safe mode feels less like a technical failure, and more like someone's hand covering your eyes just when you've almost made out a silhouette in the dark. The most frightening thing about such stories isn't the anomaly. What's most frightening is the discipline with which it's repeated. It's as if the object isn't simply passing by, but testing how predictable we are. And we're predictable. We publish observation windows. We plan our sightings in advance. We schedule our observations so everyone is watching at the same time. We draw a map of where our gaze will be on paper. And if you know where the gaze is directed, you know where to appear, or where to disappear, or which device to force into safe mode so that the picture remains incomplete. At the end of the hour, when the false star should have disappeared, the amateur's archives are left with raw files. They're not yet beautiful, they're still noisy, but they contain the most important thing, a repeatable dot position. And at this point, the next stage begins. Not observation, but a struggle for interpretation. Because the same point can become a sensation, a mistake, and a reason to close the archives even further. While Hubble remains silent, what is usually considered Plan B suddenly becomes work. Amateur crews, university observatories, and disparate spectrographs, which no one coordinated in advance. The most frustrating thing about amateur data is that it doesn't have to be pretty. There's no marketing, no perfect picture. There's only raw signal and the stubborn repeatability of a point that stays close to 3, I/ATLAS. Half an hour after the dot appears, normal scientific reflection begins. No panic. Checks, dark frames, flat fields, comparison of the star grid, search for hot pixels, cosmic rays, and stray reflections. And all of this quickly comes down to one problem. The false star behaves too disciplinedly. It appears not as a dirty glint, but as a compact source with a profile similar to the real object. Someone tries something simple. If it's a flare, it will behave differently on different optical systems. But the point holds equally reliably on a DSLR system and on another camera with different geometry. The next step is more rigorous. Spectrum. Not for aesthetics, but to answer one question. This is sunlight reflected from dust, or the spectrum's own radiation, albeit weak, but its own. The first spectra are arriving late because no one planned this work as an official campaign. And yet, they're coming, and they don't look like what everyone expected, a random brightness node. In reflected light, you see the solar spectrum, albeit distorted, with characteristic lines. In natural radiation, the lines will be different, and the worst thing is if they are clean, like those of a technological source. One operator writes in the general chat, dryly and almost rudely, the lines don't match the background. He's not saying it's artificial, he's simply stating a fact that they don't want to put into words. Meanwhile, other work is going on inside NASA, dirty, bureaucratic, and yet incredibly fast. First, there's a temporary publication restriction, then a safety consultation, then a calibration recheck. The trickiest part about these schemes is that everything looks legitimate. No one says, hide it. They say, check it again. And by the time you check, the news cycle has passed and public interest has waned. But now the window doesn't pass because the dot has flashed a second time, and people are already comparing the two events. They construct them as a repeating plot, and repetition kills the word coincidence. In one of the scientific units, someone pulls out the archive for the first safe mode and places the latest telemetry next to it. And then comes that moment when the lock clicks in your head. The sequence before entering safe mode isn't just similar, it's structurally identical. First, a slight degradation of tracking, then a series of short corrections, then an increase in conflicting sensors, and then a protective transition. This happens when the same external condition repeatedly forces the system into a state where it chooses safety. It doesn't break, but retreats to a predetermined mode. And that's precisely why the public routine failure sounds like a mockery, because routine doesn't repeat itself strictly within the same scientific window, if that window is known to the entire world in advance. One engineer, a man not accustomed to drama, asks a question that leaves the others momentarily silent. Are we sure this effect is directed at Hubble and not at what it's trying to see? Because if the impact is directed at a target, then Hubble isn't the cause, but an indicator. It's simply the first to honestly act as a danger sensor and go into defense while others try to catch up. And then comes a step that in normal life is only done quietly. They try to understand what exactly the system sees before entering safe mode. Not through the eyes of a human, but through the eyes of the targeting algorithm. They take raw images of a star field, compare them with catalogs, and look for localized overexposures and stray structures that could throw off a star tracker. And they find a strange spot. A zone appears near the false star's supposed position, where the star tracker begins to see stars in places other than where they should be. The shift is small, but for the tracker, it's like the floor shaking under your feet. And if this had happened only once, it would have been written off as a coincidence, but the sequence repeats itself. It's as if a local optics appears near the object, replacing the geometry of the star field. At this point, the first truly unpleasant hypothesis is born. A false star may not be an object in the conventional sense, but a phenomenon that creates a point source and simultaneously distorts landmarks. In simple terms, it might not be a flashlight next to a comet, but a field node that transforms space into an instrument. And then the question, what is it, becomes what does it do? One astrophysicist writes succinctly and angrily, if it's a lens, it doesn't have to be massive. He's talking about a gravitational lens, but he himself understands that the scale doesn't match what we're used to seeing. Another suggests something even more terrifying, a plasma structure that functions like active optics, something that doesn't simply reflect light, but shapes and directs it, as if a small camera were hanging next to the object. And then a second coincidence occurs, one that's downright creepy. During the moments when the false star is visible, 3I/ATLAS's jet pattern changes, not chaotically, but as if something were switching. It doesn't necessarily have to be an engine. A small adjustment in the emissions is enough to change the plasma distribution around the core. And if the distribution changes, so does how light travels and what the sensors see. The result is a combination that no one is happy about. The jets draw the environment forms a dot. The dot disrupts the tracker's landmarks, and the tracker diverts Hubble into a defensive mode. Everything appears to be a single mechanism. And that's not the worst part. The worst part is the global synchronicity. At the same hour, several ground-based systems are recording brief gaps in tracking precisely in the target area. It's not broken everywhere. It's a localized problem, limited to one patch of sky and one object. It's as if a zone is emerging around 3I/ATLAS, where the instruments are starting to float. At some point in a closed call, a phrase usually forbidden to be uttered appears. It's like shielding. The word sounds technical, but its meaning is human and very simple. It's as if the object can be visible to some and invisible to others, or can choose who to allow to see and who to leave with a regular glitch, and a nice, official explanation. And here's where the false star ceases to be a mystery for its own sake. It becomes a marker of a regime, like a light on a control panel. If it lights up, it means the system has entered a phase beyond our control. By morning, the amateurs already have a series of frames. Not one, not two, several. A dot appears, hovers relative to the comet, then disappears. And each time that same uneven patch of the field reappears nearby, they're trying to calculate parallax. If a point is close to the comet, its position relative to the background will vary slightly at different points on Earth. If it's the background, there will be almost no parallax. And here's where the real headache begins. There's parallax, but it's strange. It's as if the point isn't sitting at a constant distance, but breathing across the distance, changing its effective depth. This isn't how a normal satellite behaves, nor does a normal star. It resembles a structure that isn't simply nearby, but is adjusting its position or its appearance relative to the observer. By evening, NASA had a draft internal report that no one would officially sign off on. Probable functional relationship between emission mode and tracking degradation in the target region. In human language, it sounds even worse. When he does this, we go blind. and not entirely, but carefully in places, as if someone knows what's most important to us. And then one man, that same no-drama engineer, takes a step that breaks everyone's conventional logic. He asks a question not about Hubble or the dot. He asks about the schedule. Who first announced the false star's appearance window? Not in the sense of who invented it, but in the sense of who gave the world the coordinates and time so that the entire world could be synchronously aimed like a searchlight. Because if the object reacts to the very fact of coordinating observations, then it doesn't need to guess. It only needs to understand our discipline, our habit of being predictable and precise. And then the second safe mode isn't an attack on the device. It's a response to our ritual. We lined up to watch, it lined up to respond. And the response seems to be able to turn off vision, leaving no trace. In the last minute of the window, the false star flares again, fainter this time, as if reading the passage. After that, the jet pattern changes by a few degrees and fades. This movement is too small to be noticed by the viewer, but to those watching the data, it looks like a period at the end of a line, like the end of a command. The first alarming signs emerge not in the beautiful images, but in the supporting data. These are the files that no one usually looks at because they're about calibration and not about sensationalism. By the morning of December 22nd, a strange void appeared in the archive. The catalog contains records, the names match, the timestamps match, the checksums are present, but inside, instead of a frame, there's a neat placeholder with zero data. This isn't what file loss looks like. Loss is always messy. Bad blocks, red errors, random trailing edges. Everything here is too neat, as if someone knew in advance exactly how the other one would check. A couple of engineers at NASA are starting to dig in their own way. They're not arguing about what it is. They're looking for the point where the chain breaks. Reception, buffer, pre-processing, packaging, sending, archiving. And the chain breaks in one place. Not on the ground, not in the public archive, but before the data becomes data for science. It breaks in the zone where the device itself decides what constitutes reality. The report phrases it rather boringly, automatic frame exclusion based on internal quality criteria. If you read it quickly, it sounds like standard protection against junk and interference, but there's a number there that's unnerving. It's not random frames that are excluded, specifically those that fall within a narrow window around the appearance of a false star, down to the second as if on a ruler. At the same time, another packet arrives that shouldn't have clarified anything. It's a file with star tracker telemetry, and it shows that the uneven field appears slightly earlier than the false star. That is, the dot in the frames may not be the cause, but the effect. First, the system loses confidence in the stars. Then a compact source appears, appearing as a replacement for the reference point. Someone uses the word substitution cautiously, not in a mystical sense, but in a technical one, as if an alternative set of navigational reference points were created in the target area. This explains why some telescopes see a dot, while others see a flat background. If the system has an internal filter that decides what constitutes an artifact, it only needs one signature, and there is a sign. Several devices show the same tiny signal, a brief burst in one channel, similar to narrowband interference, but too stable in shape and duration. On Earth, communications engineers favor this format because it's convenient for synchronization. In space, the guidance is usually less polite. It's jagged, random, and doesn't repeat itself perfectly. While some discuss filters, others return to parallax. If the point is near 3I/ATLAS, its shift between observers on different continents should be predictable and smooth. But the displacement behaves as if the distance to the point were changing abruptly. It's as if the source weren't fixed in a single geometry, but were moving along the line of sight without changing its angular position. It's like a trick in optics. On Earth, you change the position of the lens, and the image jumps in depth. The angle is the same, but the perception of distance changes because the way the point is formed changes. This thought gives me a chill, because then the false star might not be a comet's body or satellite, but an effect created around it, like a working tool. And if it's an instrument, it's not constantly on. It's activated when we line up and try to look at it simultaneously. It's as if the object is reacting not to the light, but to the fact of observation. In a private call, someone suggests checking the correlation. Not with the sun, not with the orbit, but with the campaign schedule, with the moments when major observatories synchronize their windows. The result is too neat. Peaks in the uneven field and switches to protective modes occur near such windows more often than mere noise would suggest. It's not an absolute guarantee, but it's a pattern. Then a new version emerges, more vicious and more practical. 3I/ATLAS doesn't hide. It creates conditions around itself that force our sensors to retreat to avoid failure. It's a clever way to remain invisible. No need to jam the signal, no need to break the device, just give it a reason to panic and turn itself off, following the instructions we wrote ourselves, and this is where archival stubs begin to look like something more than just filtering, because filtering usually leaves a trace, a label, a reason, a flag, an explanation. Here, instead of a reason, there's nothing. The system says, there was a frame, then says, there isn't a frame. And it does this in such a way that external audits see a perfect accounting of events without any substance. Against this backdrop, ground-based observatories are experiencing a quiet fever. They're not saying they're hiding us. They're simply suddenly stopping publishing raw footage and switching to processed images, because raw footage is the only place where you can spot anything wrong. Everything is smoothed out in post-processing, noise is removed, the background is leveled, artifacts are thrown out, and if the artifact is the goal, that's it. One of the private users makes the right move. He posts not just a single image, but the entire chain. Raw, dark, flat, stacked, and the false star sits where it belongs, in all layers. This breaks the convenient argument that you have a glare. The glare exists in a single layer. It floats. It changes shape. Here, the dot repeats, as if it were being drawn not by the glass, but by the section of sky itself. And again, a coincidence, almost simultaneously with this post, several accounts that were discussing the window coordinates were blocked and received strange access errors to shared trackers. Not a mass purge, but targeted, specifically at the people who created the schedule. It looks too much like an attempt to disrupt the synchronization so that the next important hour won't be so streamlined. At this point, a new line of action is emerging within NASA. If Hubble is vulnerable to an uneven field, then we need to look at it differently. Not through the eyes of a tracker, but through the eyes of an instrument that doesn't care about the stars. They're raising data on other platforms where targeting is structured differently. Things aren't smooth there either, but there's no uniform recourse to defense. Instead, something else appears. Localized background spikes. And these bursts are strangely connected to the direction of the 3I/ATLAS jets. It's as if the environment around the object is being restructured, altering the transparency of space for seconds, like a thin film being stretched and released. Then the pseudostar ceases to be a dot. It becomes the tip of an iceberg, a marker that a system capable of forming structure in plasma and dust is at work around the core. The structure can serve as a screen, it can serve as an antenna, it can serve as a lens. And the scariest thing is that all three functions don't contradict each other if you have control over the density and the field. By December the 23rd, a rough outline of events emerged, compiled from independent sources. A window of synchronous observations, tracking degradation, a false star outburst, a change in the jet pattern, and gaps in the archive. It looks like a script, but it's too engineered to be a fantasy. There are no beautiful words. It's just sequences that repeat and fit together into a single logic. And the revised trajectory after December 21st fits uncomfortably into this logic. Not a close approach, but a flyby. It's as if the object is hovering at a distance where we can see it but not reach it. It's not the distance figure that's scary, it's the geometry of the approach. It's where radar and optimal imaging yield the best results, and that's precisely where we start experiencing inexplicable failures. For the first time, the word scanning sounds not like an artistic metaphor, but rather like a working term, because the jets begin to draw a repeating pattern with the same pitch, like a scan. To put it simply, it's like a beam sweeping across a sector, scanning the space. Not constantly, but in bursts. And each time, in those minutes, a false star appears nearby, like a marker. The decision makers are faced with a dilemma. If it's a natural phenomenon, it must be published immediately. Otherwise, it will be a scientific disgrace. If it's not a natural phenomenon, publication could trigger panic and a political upheaval. And that's why only one word comes out: a typical glitch. Because that's the only phrase that maintains the facade while inside. People try to figure out what exactly is looking at us from the other side. Then history takes a step that makes many people's hands tremble for the first time. One of the closed radar arrays records a stable reflection in an area where the comet shouldn't have a shape. Not a random blip, not noise. A steady return of the signal, as if there were a structure there that held the reflective surface, even if only for a few seconds. And this reflection appears at exactly the same type of important hour when Hubble's telemetry faltered again, and the false star flared up and disappeared. Half an hour after the first blip on the military radar, a strange silence sets in. It's not "no one's answering," but a procedural silence. A single word appears in the chats: freeze, and everything that was accessible a minute ago becomes inaccessible. Radar itself doesn't see the comet. It sees something that, by definition, shouldn't be present on a comet. A stable reflection that behaves like a surface, not a dust cloud. Radars prefer dense shapes, and comets are usually about scattering. That's why this thing captivates anyone who's ever worked with radar. From a cloud, you get a clutter of noise, a burst, then a blur. This is different. The signal persists and repeats, like an object's signature with geometry. The most annoying thing about these reflections is that they're easily mistaken for interference, but almost impossible to confuse with a natural tail. Interference doesn't sit in one place relative to the target. It dances, and here it is. A few minutes later, a second coincidence emerges. The radar time slot falls precisely within the window where private operators in both countries again detect the same false star. And the false star is not positioned against the background, but on the comet. If these were two separate phenomena, they would be out of phase. One caught the dot, the other caught the noise, the third caught the artifact. But here, a trinity comes together: optics, telemetry, radar, and all within a single corridor of minutes. In a closed conference call, no one says ship or probe. Everyone speaks in dry terms because dry terms are less frightening. Coordinated anomaly, non-profile reflection, stable component. But behind these words lies a simple idea. If the reflection is stable, then there is a surface that maintains its orientation over a short period. Or there's a structure that itself maintains an effective radar cross-section. And here's where the false star ceases to be a suspicious point and becomes a possible mode marker. It's as if the object turns on something nearby, and at that moment we have two effects at once: optical and radar. What follows is what will be publicly referred to as a routine security check. In reality, it's not a check, it's a quarantine. Access to raw radar data is restricted at the key level, and publication windows are closed under the pretext of regulations. That same day, several scientific groups receive letters with the same wording. We ask that you temporarily refrain from making any interpretations. The letters are addressed differently, but the tone is the same, as if they were written by the same person. And against this backdrop, Hubble is once again doing what it does only in extreme cases. It's entering safe mode for the second time, right in the predicted window when the false star should reappear, based on the previous step. This no longer looks like a coincidence, because two coincidences can still be pushed aside as an unfortunate coincidence. Three coincidences begin to smell of a system, and a system is what we least want to acknowledge. When Hubble goes into protective mode, ground-based observatories experience the exact opposite. Their sensors aren't blinded. Instead, they detect a background surge, but only in a very narrow region. It's as if the environment around the object changes for a second. Not the brightness of the comet, not the tail, but the transparency of the space around it. As if someone had momentarily stretched a film, and the light flowed differently. This is difficult to explain with conventional dust physics. Dust produces scattering, but it doesn't produce a neat, localized swelling of the field that repeats at regular intervals, and it's the intervals that become alarming. One of the analysts draws a simple diagram. Time is on the axis. Events are represented by stripes. A false star, a radar reflection, a tracker glitch, a background surge, a change in the direction of the jets. The stripes form a rhythm. The rhythm is like a sweep, a scan, as if the object were combing a sector of space and each pass was marked by two markers, an optical dot and a radar response. And then a theory emerges that sounds too engineered to be dismissed as mere panicked fantasies. A false star isn't a body. It's an active marker, a pseudo-source created near an object. Why create a pseudo-source? Because it can serve as a reference point. It can be a lure for algorithms. It can be a beacon for another system viewing it from a different angle. In human technology, this is a normal idea. You don't always want to shine a real antenna. You put a mark that looks like a star and build geometry around it, especially if you don't want to be measured directly. And here's where another detail enters the story, one that's downright disturbing. On several telescopes with different filters, the false star displays a strange color signature. Neither a star nor a lens flare. It doesn't behave like a hot source or like a reflection of the sun. It behaves like a narrowband signal that disguises itself as light. In other words, it doesn't shine, but rather encodes. No one says it out loud at an official level, but the thought occurs to everyone at once. If it's code, then it's not a random process. And if it's code, then the object has a purpose beyond just a graceful flight. That same night, reports of strange steps in the dot's brightness began popping up on private forums. It didn't fade in and out smoothly, but seemed to cycle through levels, just enough for synchronization. Meanwhile, military radars are producing another blip. not as clear as the first, but with the same character, and this character is more important than the value. It's stable again attached to the comet, again in the window. After this, the words normal glitch begin to sound like a defense not against panic but against facts, because glitches don't form a repeatable pattern, glitches don't choose a schedule, glitches don't align with the rhythm of the streams. By the morning of December 24th, a quiet decision is forming within. If the subject truly turns on the mode, then the next step must be taken not where they want, but where they're uncomfortable. A different angle and a different time are needed, and so windows begin to shift. Observatories receive new graphs, private sites randomly stop matching, and public trackers suddenly begin to float in updates, as if someone is deliberately introducing a delay. But 3, I/ATLAS doesn't seem to be getting lost. It's rearranging its jet patterns, not chaotically, but at the same rate, and the false star reappears, only slightly shifted, as if it's adapting to our attempts to move away. This is the moment when even the calmest people stop arguing about terms and start talking about behavior, because physics can be strange. But behavior is something we recognize immediately, even when we don't want to. The morning doesn't begin with new photos. It begins with some of the old photos disappearing. It's not post-deleted or page didn't open. The very chain of links that people followed overnight like a ladder, piecing together the picture, disappears. This is an important detail, because when you truly have just a glitch, you don't hide anything. On the contrary, you reveal more to cover up the issues. But here, the opposite happens. Any piece that could have been glued together becomes less accessible. Within agencies, they have a catchy term for it: data sanitization. In layman's terms, it's this: they're afraid of what's being pieced together from various independent sources. Not just one sensational shot, but rather consistency. So the daily plan changes abruptly. They stop caring what exactly the false star is. They set a simpler and more vehement goal to prove that it follows the schedule and therefore can be caught in the forecast. And for the first time, they're doing this not based on best geometry, but on the worst. They choose a window where the object is less visible, where the background is more complex, where errors are more likely. The logic is simple. If the pattern repeats even there, then it's not a matter of optics, processing, or luck. They're incorporating things that are usually kept away from public science, not because the military knows everything, but because they have different tools. They don't need a pretty picture, they need the fact of reflection. Radar calculations are based on the principle of everything is against us. They assume minimal values, assume the worst possible orientation, and give themselves the right to fail. But this is precisely the scheme that preserves the most important thing. If a signal still surfaces, it's no longer a fluke, and it comes up. It's not like the first time. It's not as clean. It's as if it's been cut off, as if the object isn't showing its full surface, but only a thin edge. But the edge holds, and it holds for exactly as long as the false star held in the previous windows. This is where people really get cold feet, because a coincidence in timing can be explained in many ways, but a coincidence in timing and duration at the same time is like a signature. One of the operators puts it most simply: it turns on the mode for a fixed length. And there's no fantasy in that phrase. It's just engineering habit. If something turns on the same way, it's a command or an algorithm. After the third mark, a requirement arises: synchronize all observations down to the second and merge the marks into a single timeline. Optics, radar, spectrum, satellite telemetry, geomagnetic sensors, even noise on some radio links. And yes, they're pulling everything there. Because now, the question isn't, is the comet weird? The question is there interaction with our infrastructure? From the outside to the average person, the day looks dull. There's nothing on the news. The feeds only show a few phrases about another trajectory update. But inside, the pace is as if they're trying to hold water in a leaky cup. And 3, I/ATLAS, as if sensing this, begins to behave more subtly. The jets don't simply change direction step by step, as before. They begin to draw a pattern that resembles a scan, but it is no longer linear. It becomes arced, sectored, like a scanner that has rebuilt its grid to accommodate a new target. If before this looked like combing, now it looks like mapping. It's as if the object is trying to assemble a model, not of just one space, but of space plus a noise source. And suddenly we turn out to be the source of the noise. And here's where the fourth layer of history emerges. What people on Earth had dismissed as weather, storms, normal activity begins to fit into the same timeline. Somewhere there's a storm warning that's out of season. Somewhere there's a local magnetic disturbance, which instruments register as a short bump, without the usual long tail. Somewhere there's a weak earthquake with an odd waveform. No one's screaming, it was a comet. All intelligent people know what paranoia sounds like. But when you see these events occurring near the regime, you're obliged to at least ask, Coincidence or correlation? Because if it's a correlation, it means the object is doing something that affects both heaven and earth simultaneously, and then the false star might not be a beacon. It might be a side effect of a regime that involves a different type of interaction. That's why the next plan includes not only telescopes, but also a network of instruments that aren't typically attached to comets at all: global magnetometers, ionospheric stations, and radio noise monitoring. The most distressing thing about this story is that the nothing unusual lingers ever more quietly, because anyone who sees this timeline understands something unusual has already happened. The only question is who will be the first to dare to put it into words. By evening, they take a step rarely taken in conventional science. They stage a provocation. In other words, they create an observation schedule that deliberately looks like a trap. It's as if they're telling the target, "We're waiting for you here, and like this." And they do it in such a way that they see this coordination through our publications, our trackers, our leaks. The idea is brutal, but logical. If an object responds to coordination, it doesn't have to read our chats, it only needs to monitor our behavior. Public windows, synchronized telescope rotations, identical exposures, and here's what happens. At the moment when everything is supposed to happen according to the provocative schedule, the false star appears in a different place than expected. It appears a little earlier and a little to the side, as if he hadn't been caught, as if he had tested the trap and avoided it. This is the second time they see not an oddity, but an answer, because randomness can be beautiful. But randomness doesn't behave as if it understands the concepts of wait and go around. After this, Hubble didn't go into safe mode again, and that's also strange, because if the glitch was hardware related, it should repeat itself randomly, but it did repeat where it shouldn't, and it doesn't repeat where it should. A theory emerges inside that sounds worse than all the others. Safe mode wasn't a malfunction, it was a protective response to an external force hitting a specific window. Which means the object isn't just glowing, it might actually be working. And if it works, it's logical that it will avoid being seen the way we want it to be. It will leave us with only as much data as is safe for its purpose, because he might have a task. The perfect shot doesn't come from NASA or Hubble. It comes from the ground, from those same boring optics that are usually relegated to the bottom of the list because they don't create sensations. This isn't a, wow, look at that comet picture. This is a shot where the stars are in place, the background is clear, and only in one area does the sky act as if it's been gently touched with a finger through a cloth. At first, it looks like a processing artifact. That is, until another operator in a different city posts their raw footage and points to the same area. There's no text, no explanation, just coordinates and time. The difference between these people is that they don't even know each other. They have different cameras, different programs, different habits, but they share one thing, the window. When the false star was supposed to reappear, their shots don't feature a star in the traditional sense. There's a tiny dot, yes, but that's not the important thing. What's more important is the subtle geometry surrounding it, too neat to be dust. When engineers see something like this, they first look for the most trivial things, a matrix defect, a cosmic ray, stray light. But the defect doesn't jump around the frame synchronously for two people. Their next step is always the same. Check the star alignment. They overlay the images, align them with the field, and realize that the dot is relative to the comet, not the camera. Then a word no one likes to say out loud is placed on the table, accompaniment. This is the behavior when a source moves with an object and maintains its position in its vicinity. This word doesn't mean ship or probe. It means something worse. It means there's something nearby that behaves like part of a system, not like random junk. At this point, it's not the science coordinators who start calling, but people who shouldn't be calling about comets at all. And they're not calling to find out anything. They're calling to find out who's already seen it. Because the most dangerous thing right now isn't the point in the sky. The most dangerous thing is that such images could be shared with hundreds of observers. And then data sanitation would become impossible. And as if in response to this thought, the radar line turns on. The same one, closed, without pretty pictures. There will be no tail or shine. There will be only a number, a reflection, and time. The fourth mark doesn't arrive as another dot. It arrives as a drawing. Not an image, but a structure in the data, as if the reflection stretches out in a thin strip and for a split second disintegrates into segments. It's as if you were shining a flashlight on a spinning, thin frame. This wouldn't be possible in a normal comet because the dust cloud doesn't provide a stable mirror. It creates noise. There's noise here, but underneath it, the form holds. And the form isn't chaotic. It's repeating, as if the object produces the same profile at the same angle. They're tempted to call it a panel, because a panel produces a sharp jump in reflectivity and then fades away. But they don't call it that. They call it something more gentle. Anisotropic scattering. Words don't change the essence. This evening, for the first time, it becomes clear why the false star is held relative to the comet. It may not be a source of light, it may be a reflector, and if it is a reflector, it could be part of something larger. Not just a ball next to it, but an element that works together with the core, like a module, like a remote unit. In a parallel room, people are collecting Hubble telemetry, the same one they called normal yesterday. There is indeed a pattern there, but it doesn't look like a malfunction. It looks like protection. Before the first transition to safe mode, it is not a power supply error that increases, but a short surge in one of the channels, as if an alien impulse had passed through the system and the automation had said, hang up. Before the second safe mode transition, the burst was almost identical. Not identical, but all too familiar in shape. And most importantly, it occurred in the same type of window where the false star was detected. Then a theory emerges that is both logical and repugnant. Hubble isn't going blind. Hubble is evading. It's entering a mode where there's a risk of receiving data that could harm it. If this is true, then the impact was real. Not at the level of rumors, not at the level of processing, but at the level of the equipment, which in a vacuum should be as noise resistant as possible. That same evening, someone very cautiously brings up the scanning topic again. Because the 3I/ATLAS jets have been changing their pattern in the last few hours. They're no longer a smooth sweep, they start coming in series. 3 short shifts, a pause, then a long shift, another pause. It looks like encoding, as if the object isn't just moving the spike, but transmitting a mode. And here comes the terrifying thought, previously suppressed with jokes. What if these jets aren't for propulsion or beauty? What if they're part of a communication or sensing system? In normal science, they would say no data at this point. There is data here, it's just inconvenient. It doesn't fit the picture of a comet simply melting and tumbling. So they do what everyone does when they're missing a single piece of evidence. They create a cross-check with no right to match. The optics are aimed at one window, the radar is working in another. The radio spectrum comes third, and if the pattern repeats in 3 channels at once, it's no longer just an illusion, it's an event. On the night this scheme is launched, the false star doesn't appear. And at first, this seems like a victory, because if it doesn't appear, it means the trap worked and everything was a coincidence, until one of the spectral channels displays a strange line, a line that shouldn't be present in such a mixture and which appears for exactly the same duration as the previous window. The line is short, thin, and disappears as if it were turned off, and it never returns. Not because the device is broken, because the background remains perfect. This is the moment when they run out of weak words, because the line turned on and off sounds like work. And work implies management. By dawn, they understand the main thing. The object isn't simply avoiding our eyes, it's choosing exactly what we see in each channel, and it does so in a way that makes us argue among ourselves. For opticians, it leaves a beautiful image and a small dot. For radar operators, it gives a shape that can be called anything but a frame. For the spectrum, it gives a single click, and that's why silence becomes a strategy. Because if we acknowledge that this is a system, we have to admit that we're not dealing with a celestial body, but with something that acts. And anything happening close to Earth always turns into politics, into fear, into a chain of decisions that cannot be reversed, especially when the closest approach is just around the corner. This morning, a new order appears, quiet and unsigned. No unified public windows, no synchronized publications, no everyone watch at the same time. Because according to their new logic, the object doesn't react to us individually. It reacts to our coherence. And so, to see it honestly, we must stop being organized. And this is the most humbling thought of all, that the moment humanity first tries to work as one, it turns out to be the very signal that someone responds to.